regarding the nuclear power plant, we have done independent tests on it, precisely because it was closed for the reasons that are geological, that it's on a fault and it's close to a volcano. I could not accept that a $2.3 billion plant could have geologic reasons for not being operated. So I have done independent tests, which I funded myself. These are gas tests, electrical resistivity, seismic refraction, just to prove or disprove if there is a fault. Because if there's really a fault if the plant is built on the fault, then it should not be operated at all. But if the fault is some distance away, then it can be engineered. The design can probably withstand that. So it's a matter of scientific testing. I have the data, I'll want it open. Anyone who will claim otherwise should disprove the data that we have. Because once the fault moves, the fault is very deep. It's several meters or maybe several hundred meters, maybe to a kilometer. So any time it moves, if you're on top of it, masisira talaga siya. What you do to evaluate these things, so if you're not on the fault, what is the minimum distance that you should have? It will depend on what we call the peak ground acceleration. Because once a fault moves, there's going to be acceleration on the ground. Now the PGA, the peak ground acceleration, you design on that. So for example, is the plant, I think, designed to 0.4 G, which means that it can resist seismic forces equivalent to 5 meters per second or 4 meters per second. Now, the closest fault to the plant, if ever it exists, is the Lubang or the Lubao fault. You can see it in the satellite photographs that there is indeed a linear structure. This is probably a fault. And then, since if you have a nuclear plant, that will raise alarms. My perspective there is that draw the fault, verify where the fault is on the ground, so we will know exactly where it is relative to the plant. Once that's done, then we can test what's the maximum earthquake that can come from that fault. And typically, the maximum earthquake is proportional to the length of the fault. First, you have to establish it's active. PHIVOLCS has not even hasn't classified as active. In fact, in my opinion, they should be the one to have the final say on this. If there was an active fault, it's been closed for 20, 30 years. It should have expressed itself in the surface. None. Many countries in the world that have nuclear power are in the ring of fire. Japan has 55 nuclear plants, it's in a ring of fire. Taiwan is in a ring of fire. A lot of Europe, not necessarily the ring of fire in faulted areas, in South America, Mexico has, and the United States, in the eastern side, in California, there are nuclear plants there. Okay, so what's the big deal about that? As long as you design it, ring of fire means only things. Ring of fire means volcanoes and earthquakes. Back to the first argument. Although the volcanic argument and the earthquake argument is a more specific application of ring of fire. BNPP is built on the eruptive and sedimentary deposits of Mount Natib, which is a stratovolcano, an active and quite a violent volcano in its time. How do I know this? If you go to the sides of to the beach surrounding BNPP, you see lahars, ancient lahars, pyroclastic flows. These are eruption products of a violent nature. If the volcano were active, then we have a strong argument to close the plant. But only the two data points that determine the age of the plant is at what? It's at 70,000 or 60,000 years. That's quite a long time. It's even older than Laguna de Bay, which is about 25,000 years. And people are not even aware that Laguna de Bay, which has produced all the adobe in Metro Manila, is a volcano. So again, why use a geologic reason when you know it's weak? And this is my my challenge to those who are opposed to the plant. Let's put all the evidence aside. Let's put ideology aside, because this is science. What's the age of the volcano? What are the chances of it erupting? For the fault, what's the distance to the fault? What's the maximum earthquake? These issues are measurable. There should be no emotions in this. A good example to use here in evaluating is places like Taiwan. Taiwan is a lot more tectonically active than us. But Taiwan has very, very low power rates. It's one of the most advanced countries in the world, right? And they have nuclear power. You know, as I've said, BNPP was never used. So people say it's old. It was never used. There are very few moving parts in a nuclear plant. So how can you say that it's old? You know, there are existing there are 460 plus nuclear power plants in the world. We can get the median age of them. And then, you know, BNPP will probably be better designed than more than half of those. So, you know, what's the problem? And in the United States, they have far older plants that are being recommissioned and extended and extended because nothing has happened to the plant. Okay. Now, personally as a geologist, why am I for nuclear power in the Philippines? I'm a geologist, and then we look for mineral resources. We are, for example, the #1 supplier of nickel in the world, and nickel is used in stainless steel manufacture. And to make stainless steel, you need 3 elements: iron, nickel, and chrome. We have the 3 elements in the Philippines, but we cannot even have a steel plant because power is expensive. So we have to export 30 million tons of nickel ore to China and Japan. If power were cheaper, we could process them here. So can you imagine if we had our own steel industry? It's insulting for the Filipino that even the simplest nail has to be imported, and probably the ingredients of that came from the Philippines. This is the reason why I'm for nuclear power. Ask your relatives who are abroad, #1. What is the cost of power where you're working? The cost of power relative to your take-home pay. And what is the cost of power here in our country to the take-home pay? That is a very important decision. That's #1. Then, second, you can ask those people in those countries, is there a nuclear plant where you're working? Maybe you're not aware, but there's probably one. So, you feel safe working in a country with a nuclear plant. Why can't you feel the same here? And would you agree to the insulting thing that the Filipinos can't handle technology? There are 10 million Filipinos abroad. Of course, that's a mix of, seamen, maybe domestic workers, caregivers, but many engineers. I can tell you, if we build a good nuclear power plant with good pay, they'll come back.